All right, so hopefully the test wasn't too bad. Um, let's see. I got a bit sick over the weekend, and I kind of lost my voice. Not as sick as I sound, which is very sick, but I'm not nearly as sick as I sound. So hopefully the test wasn't too awful. So I've been looking at the schedule and the amount of time we have left, and also how much, and some feedback. And people, we really don't seem to have time for a third time lab, right? So, and also you guys seem to hate them, uh, so I tried it this semester because people wanted to have, because that's what I got. That was something that was I had gone based on previous feedback. Um, so I think what I'm going to do as a result is that I'm going to increase the worth of the. So since we're not going to have a timed lab, we're going to just simply make the times right. The timed labs are still going to be worth what they're worth, which is 5% per timed lab. But the final exam will be worth 5% more. So I think that bumps it up to 25% in the syllabus. Yeah, because it's 15, 15, and then I had 20 for a total of 50%. So we'll bump this up to 25% for the final exam. Right? Does that sound good for everybody? I'm seeing a lot of nods. Okay, so we won't have a timed lab. So we're not going to have a third timed lab. I think that at least for you guys, the timed labs are for 1068. The timed labs are a bit of a mess. Maybe if I did 3 exams rather than 2, that might be a bit better, but we'll see. So with that being said, we really only have 2 things to cover. I gave you a new homework. You should be able to do most of it except for the first problem on it, which is weird. So you can do like the second and the third, but the first one, that what you need is the whole idea of static methods and static variables. That's going to be that we're going to talk about that this lecture. So let's review what we learned from last week because that was a bit much. So we've learned that basically we can write Java files, and they come in 2 forms now. We're going to learn about the third form this lecture. So the first form is what we've been doing so far, which is a program, right? It's a program. It's a program because it has the main method in it, right? And you can run it, and it runs as a program, right? It's a bunch of instructions that your program runs. So here we're creating a new circle with a radius of 7, and then we're printing here we're printing out the area of that circle, and that is a program, right? We gave it instructions, and it did it. Wow, my voice really sounds terrible. Glad I decided to pull the mic over here, though. Okay. So the other type of Java file we can write was a class, right? And that's what we've been focusing on for the past week or so, which is we learned how to write methods, which are small mini subprograms, right? And here we're writing classes, which are essentially organizing a bunch of variables together and a bunch of methods together into one new data type, right? So just like string isn't data type, somebody had to write that, and this is how they did that. Somebody had to write a circle class. Somebody had to write a scanner, so they did that. And they just built it up from stuff. So we built a point object previously, which we defined as having x and y. And remember, the private just simply means that you can't reach in and tweak them outside of the point class. You can change them inside the point class, but not outside, right? And we defined classes as roughly having 3 portions. They have the variables, the constructors, and then their methods, right? So we defined the point as having x and y. Here's how if you don't provide any parameters in the constructors, right? We say that the x has and y get a default value of 0 and 0, meaning that it's a point at the origin. And if you give them values, well, to start out with, they end up at those values, x and y. Right? And this is used to refer to this point's x gets set to the local variable x, and this point's y gets set to the local variable y. Right? So you can use, so if I didn't have the this, the x would overshadow, right? And our local variable would never get set. Now, some people don't like doing this, the whole this, even though that's the way your IDE will automatically generate it. So some people will give it like the x as the variable and the y as the variable. And that's a perfectly valid choice as well. And then we have instance methods. Basic instance methods are getters, which get local variables, right? So if you have a private variable and you just provide getters, then it is a read-only variable, right? Once value gets set, you can read it, but you can't change it, which is kind of useful. And the other one is if you provide a setter, then you can change it, right? But this way you have control. You can let people only modify variables that you want to be modified. And then we have other methods like calculating the distance to another point, and then how do we draw this given a graphics. And then finally we have the toString method, which says if we were to print out this item, this object, how does it get printed out, which is kind of useful. And I was working on the circle, which represents an actual circle, right? Not necessarily drawing it yet or anything like that, but I like using the circle because it provides a great example of of why you want something called a static variable in the first place, right? So every circle, it's defined essentially by one thing and one thing only, its radius. And if we're going to bother putting it on a coordinate plane, then it's going to have an x and y. Right now, I'm going to leave the x and y, undefined right now, but the radius is what we care about, right? So private double radius because y double as opposed to int because radiuses can have be 2.5. And then we have rather than a private variable, we have a public final double pi, right? So we have a bunch of things going on here. We have the variable's name is pi, and I put it in all caps because I wanted it to be final, because that's a visual indicator that's a final variable, meaning that once its value is set, it can't change, right? We don't want to change pi. We don't want somebody to accidentally change pi from 3.14159 to anything else, right? Makes sense that you don't want to change pi. Pi is kind of important. It's a double because, of course, it's a double. So it's a final double, meaning that you can't change it once it's set, and we set it up there. And then public, that just means that, well, you can see it, right? Anybody can look at this program and see it at a circle and see the pi. Okay, so we've got then we've got two constructors. Let's look at this one first, the second one. It says if we create a circle with a given radius, we'll set the radius to that given radius. So here, if we look to our circle test, right, I created a new circle with a radius of 7. And so the circle that I created, it had a radius of 7, right? If I didn't provide one, we simply set the radius equal to 0. So we have a getter, and then we also have get diameter. We didn't need a diameter value because we could easily calculate the diameter just by multiplying the radius by 2. We have the circumference, which is, how do you calculate the circumference? That's 2 pi r. And the area is pi r squared. So we just plug those in, okay? And so it's really easy to model these shapes, right? I could have all these as static methods, right? And have a list of radiuses, right, for circles in an array or something. But having them all organized together in a single circle object makes my program a heck of a lot easier when I actually go about writing it. Okay, so the point here being is that objects aren't necessarily a necessary part of programming languages, but Java is built around doing this object-oriented programming, meaning that we create programs with regards to objects and how objects interact with each other, right? You can do it without that in Java. We've been doing it for the whole semester up till now, but making things object-oriented is much easier. Okay. So now let's go ahead and look. And remember, what's a couple things to remember is that these are instance variables. So each circle has its own radius, each circle has its own x, each circle has its own y, and each circle has its own pi. Right? And this doesn't sound like a problem, but now let's go ahead and create an array of circles, right? let's say I'm a bit mad about circles for some reason. So circles is equal to new circle array, right? A new array of circles, and sure, that sounds like enough. Okay, 1,000,000 circles. Okay, so for int I is equal to 0, I is less than circles.length, so the values for I are going to be 0 all the way up to 999,999, right? So all the valid indices in the circles array, and then I plus plus. Okay, so for each of those, right? So when we initialize this, this is about 1,000,000 nulls, okay? This is 1,000,000 nulls sitting right here, okay? And so now we need to, if we want it to be an array of 1,000,000 circles, we should probably populate it with a bunch of circles. So what I can do is I can essentially create a circle. So circle C is equal to a new circle. And let's give them all a radius equal to its index, okay? So if this circle is going to be stored in index I, we'll give it a circle. So we'll give it a radius of I. So the circle at index 2 is going to have a radius of 2. The circle at index 4 is going to have a radius of 4. The circle at index 0 is going to have a radius of 0, which really doesn't make sense, I guess, mathematically, but we're just going to go with it because I'm keeping it easy. So circles, oh, and it's telling me I can't do circle C. Why can't I do circle C? Because I already have a circle C. Right? I've created one already. I can't reuse the variable name in the same program in the same method. So it's an easy way to get around that is to just toss this. Okay. So we'll create circle C. And then we will go ahead and say circles index I is equal to C. Okay. And now, what are we going to do? We are going to do circle. So now that's really all we need to do to set that up. And so now let's go ahead and why don't we write a for each loop? So for each circle C in the circles array. And we'll go ahead and print it out. And it's just going to print out a bunch of object pointers because, specifically when I say a bunch, I mean 1,000,000 of them, because I didn't define a toString method. So why don't we go ahead and write a toString method? Public string toString. And it generates like this whole thing, this whole return super.toString. Don't worry about super. We'll learn about that later, then the next chapter. Instead, what we're going to do is just return. You want a string that represents the circle. This is a circle of radius space plus this circle's radius. And now if we run it, it gives us all the circles. So we've got 1,000,000 circles, and each of them have their own radius, x, y, and pi. So let's go ahead and look at the let's go ahead and see what the debugger view looks like. Let's go ahead and create a breakpoint here. Okay. So debuggers are pretty useful, right? They can, if you set up a breakpoint, if you get a bug that you can't really understand, like from a null pointer exception, you can set up breakpoints and run the debugging operation. And this is the big feature of IDEs, debugging. Because once you hit a breakpoint, it's going to stop. And then you can look at your program and look at all the variables in your program. Right? So the only variable we have here is the circles variable. And the circles array. And it has, it it says it has 990,900 more items in it, right? Because it's a size million array. In index 0, there's a circle. Sorry, in index 1, there's a circle with a radius of 1, an x, a y, and a pi. In 7, there's a circle with a radius of 7, and its own copy of x, and its own copy of y, and its own copy of pi, right? And in 13, its own radius, its own x, its own y, and its own pi. Now, it makes sense for each circle to have its own radius, right? That's what defines each individual circle. And if we wanted to graph it somewhere, it makes sense for each circle to have its own x and y coordinate for being the center of the circle, right? But it does not really make sense for every circle to have its own copy of pi, right? That's actually kind of a bit wasteful, right? We've got a million circles here. We need only one copy of pi because pi is this. It's not. We made it final, meaning it's not going to change from one circle to another. Okay, so it's not going to change from one circle to another. So really, what we need is just one single copy of pi. And right now we have a million copies of pi. That is 999,999 more copies of pi than we need. Multiply that by 4 bytes. Right? So 999,999 times 4 bytes, because that's how much a double is. Wait, no, it's 64 bytes, so 64 bits, so 8. And that's how many bytes we're wasting. Almost 8 megabytes. And that doesn't seem like much until you go up to a billion circles. And then you're wasting 8 gigabytes of data, right? That's a bit much. So really, we want a way to have one shared copy of pi, one copy of pi shared among every circle instance. An instance, right, of an object being like, the created version of it. How do we do that? With a single word that we already know, but now you know what it means. But now you're going to learn what it means, and that's static. Public static final double pi. The static means that so when we apply static to a variable, right? Instance variables mean it's a copy for each instance. And static means that there is one copy and it's shared among all the instances of the object, right? So that's kind of very useful here. So now if I terminate this and now I debug it again, if I go to the individual circle, each circle has its own radius, its own x, and its own y, but it doesn't have its own copy of pi anymore. But it's still there. In fact, what's really cool about it, once you make it static, once it's shared among everybody else, you can access it without an object. You can go circle.pi because it's static, right? Static means share. It means there's a bunch of ways to interpret static. I find the easiest way for a new student is to interpret it as that it's shared. It's a shared variable, shared among all the instances of the class. But really it has a kind of more complex meaning that basically means it's disassociated from any specific instance of the object. But what that means is essentially you don't need a circle variable to access pi, right? It's part of the class. It belongs to the class. It belongs to the concept of a circle rather than any individual circle itself. But as a result, since there's no one copy for each individual, since there's one copy that's shared among everybody, you can access it like this, circle.pi. Now, of course, I could go and say circles, right, the array circles 2.pi. It gives me a warning saying that you should access static variables in the static way, which is to go say the class dot this. And we've kind of seen that before in other stuff. When we specifically when we've used pi before, when we do math.pi, which has a lot more variables, right? We access it the same way. So we'll take a look at the math class in a bit. So static variable means that it's shared. And final means it's unchanged. So that means that basically that we've got a variable that's shared among everybody. It's unchanged. Public means everybody can see it. What about something else? Private static num circles. Private static int num circles is equal to 0. So this one is not static, okay? This one is not final, meaning it can change, right? And this is basically saying this is the number of circles that have been created, okay? And whenever we create a circle, we're going to just increment that. How do we know when a circle is created? Well, when we call constructor. So the default constructor calls the other constructor. So we can just put that in here, num circles plus plus. And it tells me that I should access it replace with plus plus num circles. That's not going to do anything. Introduce a local variable. No. It's just giving me a warning because it doesn't really like that too much. But here now we can keep track of the number of circles created. So now I can, in this, here I can go and say, you know, we've made plus, let me make it public for a second. We've made blank circles, circle dot num circles plus. So we've made, so now as you can see, it's incrementing and counting the number of circles that it's made. So this is a, you know, this class counts how many circles it's made. Now, so it keeps track of the number of circles you have at any given point. It still says 0 over there. It counts the number of circles made in that program, right? So when the program ends, it goes away, right? And that kind of makes sense. Of course, I don't necessarily want it to be public because if it's public, I can do this. I can say, I can modify it outside the program, and then I get an inaccurate count of the number of circles that have been created, right? So I don't want it to be public because then somebody like me might come along and say there's been 10 million circles already created. So we'll make it private instead. But how do we access it now? Well, the same way, we need a method. Specifically, we're going to need a static method. Now, when you're working with a class, so there's two different ways we're going to use that we use static method. The first way, well, technically three, but the first way is when we've written our programs before, right? When we write static methods to basically be small subroutines, okay? Right? We've done that the entire time. In fact, we just did a test that basically was all static methods, right? Okay, this one over here, when we use static methods inside a class, here we're saying, if we're writing a static method over here, we're saying that it doesn't actually need any instance of a circle to work. So public static int get num circles, return num circles. Specifically, return circle.num circles. I'm not going to use this. Right? It's going to give me an error if I use this. Okay? Gives me an error that says it says down, actually it tells me the error down here. Objects.circle cannot be referenced in the static contents. Why is it saying that? Well, remember I just said that it's a static method, which means that it doesn't need any circle to rely on. You can call it without having made a single object of it, right? Static, and we'll see that better when we get into the third type of Java program, which is a module, okay? Which is just a bit. But essentially that means since you don't need any object, there's no this. There's no this object to refer to in static methods. There's no circle here. So we refer to it as circle.num circles. I'll go through the slides as well, but so now we can go to circle test and do circle.get, assuming I can type, get num circles, and that will return the local copy of the static variable. So typically, when do you want a static method? You want a static method when you want to refer to when you need to use static variables and only static variables, and when you don't need an object, when you don't need an instance of an object, when there's no this to work off of, right? All these other methods I wrote, they needed this circle's radius, right? Getting the number of circles created, it doesn't need any specific circle. It just needs to know the number of circles. So let's look at the third type of Java program, really, and that is a module. And we've seen this before, and I'm going to pull it up over here. Math, Java, source code. Okay. So here's the math.java source code. Okay. Let me zoom out for a second, and then I'll zoom back in. So the raw. So here's the source code for Java. I think it's in the 6th version of Java, but whatever. It's going to still, all the stuff we need still applies. So it says it's in java.lang. It needs the random class, right? A bunch of comments. And then it says public final class math. The final we'll learn about in a bit, but what that means is that the final, right? Final means a variable can't change, right? So if you've got a final in front of your class, that means that it's a way to prevent your class from being changed or overridden, okay? So final, remember, means you can't change this. So final in this context means you can't change the class. How would you do that? Don't let anyone create a math object. Don't let anyone instantiate this class, right? You don't want anybody to make a math object. It doesn't make sense to make a math object, right? The math class is just a bunch of methods, right? It's a bunch of static methods and a bunch of variables we need. So remember how all our constructors were public so far? Well, public meant anybody could build it, right? So what does a private constructor mean? It means nobody can build it. Nobody can create a math object, right? I can't go and create a math object, right? Because that doesn't make sense. You don't want people to create a math object, right? So math m is equal to a new math. Excellent Tom Lehrer song, by the way. It says math is private. Math has private access. I can't create it. Right? I can create a math variable, but you can't create a math object, right? What would that even conceptually even be, right? You can understand a circle object because there's one individual circle and one individual, and another individual circle, one individual point and another individual point. But if it doesn't make sense for there to be one individual math and another individual math, then you probably shouldn't let people make individual math objects, right? That makes sense? Well, specifically, the math object part doesn't make sense, so it makes sense to prevent people from confusing themselves. So what is a module in this case? When we say a module, we're referring to basically something that's just it doesn't have a main class. It doesn't have a main method in it, right? You don't run the math program ever. It's just a bunch of static variables and a bunch of static methods. You don't ever create an object, right? So here is public static final double E, right? We know all those terms now. Public meaning anybody can see it. Static meaning that there's one shared copy. It doesn't need a class. So it doesn't need an individual object to be able to be accessed. Final meaning nobody can go into our math object and change it. Double meaning it's a double and its name, E, right? This is the, natural value E. Public static final double pi. This is as many digits as we can stuff into it. Public static double sign, right? This is the static method for creating a sign method, for calculating the sign of a number, right? And we've got, public static double max, figuring out which of these A or B is bigger, right? Given A or B, which one of these is bigger? Min, A or B is bigger. This is a ternary operator over here. You shouldn't use them. They are bad. But essentially, it's a condensed if-else statement. You can Google it if you're interested in learning about it, but it's bad practice because they're hard to read. But all this stuff, these are just a bunch of static methods in here. Okay, so static methods, right? Most of the like big projects that you work on are going to be made up of multiple classes, right? And we've kind of been doing that here, where we've had one. What we've been doing is starting to make them bigger, right? I have a circle test over here that just simply makes circle objects, right? I don't have a main. I could put a main method in here, but if I do that, things kind of get confusing, and I don't want to do that, right? I want to let people know that this is a class. This is an object. And by splitting stuff into multiple classes, though, it has some advantages. You can reuse the code, and you can split it up into manageable chunks. Although your favorite part of this is that it allows you to work in group projects, split up the work, and blame people if they don't do their portion of it, right? If you all sit down together and say, okay, let's figure out how to break this down, and we break it down into these 5 objects and give each object to a different person, right? And we all say that these are the methods that, all of our objects rely on each other's objects, right? But in this meeting, we say, okay, in order for this to work, you need these variables and you need these methods to write, okay? You need to write these methods, and I'm going to assume that your program has these public methods that my object can use, right? So I can work on my part of the work without having to rely on your part of the work, okay? So you organize it like this. This is the big advantage of one of the big advantages of object-oriented programming, which is teamwork, and splitting it up into manageable chunks. If somebody else doesn't do their work, you can literally point at that person and say, I did my part, you didn't do yours. So here's an example of like a redundant program. Calculates to see whether to see some interesting numbers are prime. So you've got all these numbers. So we've got these numbers. We check if each of these are prime. And the way we do that is we count how many numbers they're divisible by. And then if it's only divisible by 1 in itself, in other words, the number of factors is 2, we return true. And then, so again, so we've got this program one that has count factors and is prime. We have another program that has count factors and is prime. So we've got basically the same method copy-pasted into different places. So it makes sense that basically that you might want to create a module, put these static methods all into the same location so that you can call them everywhere. I mean, I've done that when I've been working on doing my coding practice, when I was going for interviews and stuff. Like here, I had code, and I had a eulerstool.py class, which I only managed to put one method in, but the idea was that I would simply put, if it was something that would be reused among a bunch of my programs that I wrote, I'd put it in there. So here we create a module called factors, which has 2 static methods, which tells whether a number is prime and then counts the number of factors. So example module classes are math, right, which we just looked at. The arrays class is the example of a module, right, because it's got the arrays.toString, .toString, and all the other arrays methods in there. There are a bunch of static methods. You don't make an arrays, plural, object. You can make an array of integers, but you don't make an arrays object. It's just a collection of a bunch of stuff. System, right? System.out.println. System is a class. Out is another class inside of it. And println is a method. So modules, right? The big thing to note about math is that it's not a complete program. You don't run math. It doesn't have a main. You use it in another program. And the way you run a module is that you do the name of the class, dot the method, and then whatever parameters it needs. And we've been doing this. If this sounds complicated, don't worry. You've been doing it the entire time, right? When we've been doing like, right? So when you've been using math.pow, right? System.out, math.pow. This calculates 2 to the 5th power, right? The name of the class, the method in the class, and the parameters. Nothing you haven't seen before. We're just finally like giving it formal names that we couldn't before because we didn't know what objects were, right? And classes specifically. I'll silence this build. So 32. Okay. Okay. And we know how to use a module because we've used it before. We use it every time we do system.out.println. We use it every time we do a math call. We just use the name of the program and then dot the method inside of it. Right, and this is just like they tried to do a simplified version of the math class, right? They didn't put final in there because that's confusing. It's just got final static int absolute value to create the absolute value, turn radians into degrees. So static members, they're part of the class, right? They're part of the blueprints for building an object, rather than part of any object itself, right? So these classes can have static methods and they have fields. They're not copied into any of the into any individual object. They're just simply shared by every member of the class, right? So if you've got a class and you say it has 2 static fields, 2 static variables, right, and 2 static methods, right, each object is not going to have a copy of those methods and those variables. What it will have their own copies of is their own instance variables and their own instance methods, right? So now we've finally learned all 3 types of variables. So you have local variables, which exist only inside of a method or only inside of a loop, only within a block of code. Okay? They're local to a block of code. Okay? Then you have your instance variables, which you get 1 for each instance of an object. In other words, each object is created. And then you have static variables, which are kind of like global variables in other languages, right? Java doesn't really have a global variable system, but static is pretty close. And that just simply means that it's a variable that's shared, or a method that's shared among every single member of the object. And it's accessed in a static context, meaning you use the name of the class rather than an object variable. You use the name of the class and then dot the method. Okay. Right, public static int the answer equals 42. Hitchhiker Guide reference right there. Private set, and mind you, because it's not final, somebody could change it. It's like a constant, except you can change its value if it's static, if it's not final. Generally, static fields are not public unless they're final, right? And you saw that when I was doing this, when I was writing the num circles over here, right? If it's public, I made it final. If it wasn't final, I made it private. So that basically people can't change it outside of the class itself. And if I make it public so it's easy to access, I make it so that it's final so it can't be changed, right? It makes sense that in the math class, you don't want your pi to be changeable, because pi changing would be kind of a bad thing for math. So here in the bank account, you've got the number of bank accounts that have been created, public static int object count, sorry, private static int object count. Every time they create a bank account, they increment the number of bank accounts that they have, and then they give each bank account an individual ID, which is saying that this is if you're the nth bank account created, then your ID is n. Static methods are easy to write. You've been writing them the entire time. The only difference is that they don't use is that it's shared by, since it's shared by all objects in the class and it's not replicated, that means you can look at it one of 2 ways, but the results are the same. If it's shared by every single method in the class, right, then this is meaningless, right? Which object am I referring to? If there's a million different objects and it's a static method, I can't use this because I don't know which of the million objects I'm trying to use, right? On the other hand, and so that's one way to view it. You can't use this. You can't use any object fields because you don't know which object. The other way to view it is because it belongs to the class, and what if there are no objects? Well, then this is meaningless. There is no object to access, right? If you can access the methods and these variables without using, without having an object, then there is no this there, right? So static methods are shared by all objects. They don't get copied into each individual object, and they don't have any implicit parameters. They don't have any individual fields. They don't have any instance variables. So static methods cannot work with instance variables. Other way around, though, instance methods and variables can totally work with statics. So we've learned there's three types of classes. You have essentially programs, which are main and maybe some other static methods, right? An object, which is a new type of, which basically is an object class, which defines a new type for a new data type in Java. Just like methods return give you new verbs, these create new nouns. They create new things you can make in Java. And modules are essentially utilities, a bunch of they're the wiring that holds everything together essentially. Okay, so those are the summary of what you have. So let me, before I go on to any new stuff, is just show you how that. Let me just talk about how that corresponds to the homework I just gave out, because I'm sure it's been busy, and so very few of you looked at it. Okay, class assignment. So we've got three things in here. The first one is to create the first one reinforces the difference between static and non-static variables and methods. So we're going to create a class called room occupancy, which records the number of rooms in a building, right? So the class has it has two fields, okay? The first is the number of people in a room, right? Each room has its own, each room occupancy object has its own, each room occupancy object represents an individual room. So each one has its own instance variable, number in room, right? Some rooms are bigger than others, so some rooms can hold 3 people, some can hold 5, some can hold only 1. Total number is the total number of people in all rooms. So you have a bunch of room occupancy classes, right? Each of them have a total number in that room. Okay? I'm sorry. Well, sorry. Number in the room is actually the number of people in the room. It's not a people that can fit in there. Some rooms have 5 people in there. Some rooms have 1 people in there. Some have 2 people in there. Some rooms have no people in there because they're not booked, right? It's however many people are stuffed into an individual room. Total number is all those things added together. It's a shared static variable. So the class has a bunch of methods in it. So this is a instance method. Adds one to a specific room. It adds one person to a specific room. And because you increment the number of people in one room, you want to also increment the number of people in the static variable, the total room. Remove one from room does the same thing, but it decrements a specific room's number of people, and it also decrements the total number of people in the room. But of course, you can't go negative, so just catch that. Get number gets the number of people in a room, and get total, that is a static method because remember, you're getting a static variable. It just returns the total number of people. It gets the total number over here. It's a getter for that. Exercise 2, some people had trouble with. So last semester, so I'm going to go over this. So create a complex number class that represents a complex number, right? So complex numbers are sometimes called imaginary numbers, which implies they don't exist, but that's not true. Complex numbers do exist. They're just complex because they use the imaginary unit, which is I. And you can actually view complex numbers as kind of like a point, just like an XY point. It makes it where basically you have the real axis, right? The A, and then you have the complex axis, which is the B, right? So complex numbers are of the form of A, right? You have the real part and the imaginary part. So check out Wikipedia if you need a refresher. So you have only 2 fields in a complex number. You have the A and you have the B. There's no need to have a variable that holds the I right? Because the I is implied, right? B is multiplied by I. So now you just need to do add, subtract, multiply, and divide. Each of these methods will take in one and only one other complex number and performs the stated operation to produce a new complex number. So the add method looks something like this. Public complex number, add complex number other. So you add another complex number to this complex number and return a new complex number, right? You're not going to change the current complex number. You're just taking like this A and this B and adding them together. And to see how to add them together, just check out Wikipedia. So these are each worth 12.5 points. So those two are each worth 12.5 points. And then this one is an actual game you guys can make. Tic-tac-toe. We can create a tic-tac-toe class, and it's going to basically, each object of the tic-tac-toe class would represent a new tic-tac-toe game. So we'll represent each tic-tac-toe board as a two-dimensional character array. Why 2D character arrays? Well, remember, a tic-tac-toe board is a grid, right? It's a 2x2, it's a 3x3 grid. What goes in the grid? X's and O's. Those are characters. So it's a character array. 3 rows and columns. And so how do you play the game? Well, we break it into what happens, what you want to happen as part of the game, right? Methods are all actions that would be taken into a game. Adding a move, which will mark a square as either an X or an O. So it's your prerogative as to basically which you want to as to how you want to implement that, how many variables you need. You can use 3 variables, one for the rows, column, and the character that you're going to put down, or you can use just 2 parameters for the row and column and keep track of whose turn it is internally. You'll need a method to display the board, a method to tell me whose turn it is, a method that will detect whether or not there's a winner, right? Whether there's 3 in a row, diagonally, or across, or vertically. And if there is a winner, you want a method to tell the user who won, player 1 or player 2, and then a method that restarts the game by just clearing the board. Okay, and that's actually like kind of a not too complicated class. Okay, so once you're done with this week's assignment is going to be the game of life. Once you're done, so the new assignment that I give out on Friday is going to probably be is kind of my capstone assignment for this class, which is the game of life. Which I have an extensive write-up which says you should totally read the link here and play a demo of the game here so you understand it. And I'll post this up for you guys, right? Notice that the first 2 sections are me telling you to play the game, right? Because if you go ahead and try to code it up, you're going to have some issues. I also will provide you some skeleton code, which means I give you essentially the class, but the code is empty. So all the methods and all the parameters are there. You just have to fill them in. Okay? And then, but that will be basically what you need to work on for your assignment here, and then we'll see how that works out for you guys. And so we're not going to have a timed lab with that, and then we're going to see what we're going to go with that. But really, we have only one more chapter left, and the rest of the semester is dedicated to honing our skills by building objects, building more and more objects to get used to the whole object-oriented programming thing. Okay. So I mentioned that there were basically there's there's 3 aspects for being a object-oriented programming language, right? There's and we covered one, which is encapsulation, which is the idea we want to make some stuff private and some stuff public, right? And then there's 2 other kinds, and then there's 2 other aspects. There's inheritance and polymorphism. And inheritance is one of the most powerful tools out there. It allows you to take code that somebody else wrote and modify it without changing the original code. Just change it and just basically automatically reusing the bits that you need and overwriting the bits that you don't need without actually touching the other people's file, which is really powerful. And then polymorphism is the last bit. So the reason object-oriented programming is kind of important is because there's this entire field of programming called software engineering that's building, designing, documenting, and making these large computer programs. And the bigger programs get, the more unorganized you get. If you try, a lot of people do try writing games, basically, as soon as they're done with their first programming class. And it ends up being like, there's nothing wrong with that. There's actually nothing wrong with that. It's a valuable experiment. But I remember that basically somebody posted, this is the Terraria clone I tried to make when I didn't know anything about programming. And people looked at it and was like, oh my gosh, I was exactly like that when I started beginning, because I knew nothing about software engineering. I knew none of the ways to usefully reuse my code. My variables were all named terrible. Because building games are really complicated. Let's see. If you're working together with other people, that's a challenge in of itself. You may have noticed that. That's tough just to work with one other person. Imagine working with 5. There's an old adage that basically, there's a story about basically a manager going to a sage programmer, and he says, so how long will it take how long will it take for you to complete this program, sage programmer? And the sage goes, if I'm given enough time to work on it myself, it will take me a year to write this program for you. And the manager doesn't like this. Well, it's like, what if I get 10 programmers to do it? Oh, well, then it will take 5 years. Okay, well, what if I hire 100 programmers? Well, I'm afraid then that the program will never be finished. So the more people you have, the more time, the more overhead there is in communicating, and that's why you get like some people developing like Slack, and other stuff, because just making it more efficient to integrate and to see what other people are doing. That's a huge thing. Getting code finished on time. Oh my God, things get delayed all the time in software. Avoiding redundant code. If you've got a lot of people working together, if they waste time making the same code, that's going to be terrible, right? You waste their, and if you got 5 people doing the same thing, then you're wasting a lot of time and money. The bigger the program, the more mistakes are going to get made. And the more text there is to read through, the harder it is going to be to find and fix those bugs. And then you're not going to catch them all. Your program will be debugged when your last user is dead, because then nobody will use it. And then finally there will be no more bugs because nobody will use it. That is when a program is finally debugged. There are always bugs. There are always going to be more bugs. There will never not be bugs. So maintaining that program and improving it and reusing it, it's going to be tough. So we want to basically reuse. So one of the big things is that we want to build it into programming languages, into modern programming languages, a way to make it easy to reuse code. We want to let the programming language handle more of that, and our programmers handle less of that. Right? So they use the law firm employee analogy, right? All employees, right? If we represent each employee as an object, right? Everybody, if you're an employee, all types of employees have the same kind of following rules: the number of hours they work, the vacation, the benefits, right? Each of them have different hour requirements. Each of them have different vacation requirements. Each of them have different benefits. And if you're in a law firm, each of you have different regulations to follow, right? Each employee gets like a 20-page manual of like common rules, common benefits, common other stuff, right? But if you're a lawyer, you also might get an additional, an addendum of different things, and a secretary might get an additional addendum of different things, right? When I came to my employee orientation here, there were some faculty members, and also some staff, and each of the staff was different, and we all got different packets, and a lot of our the stuff in our packets were the same, but then we split up because a bunch of our stuff in the packets were different, right? So we could have a 22-page lawyer manual, a 21-page secretary manual, and a 23-page manual for marketers, right? We could each make one separate, like each division can just maintain their own manual, okay? And that's one valid way to do that. Advantage of this is that basically if a common rule changes, then everybody has to update their own manual, and you only have to look in the lawyer manual if you have to find a rule for lawyer, right? So we keep separate manuals. The idea here is that if we make a common rule for everybody, then we can change it. Rather than handing out one giant packet, right, to everybody else that they all have to go through, we only hand out packets that are specific to other people. So if we need to change one thing, we basically make a common change. And if we need to find something specific to lawyers, we look in the lawyer manual. So the general rules are useful, and then specific ideas can override the other ones. So they're going to go into this relationship. But the idea here is that there's two types of relationships objects can have with each other. Okay, you have the is a relationship, that one object is another type of object. And you have the has a relationship. One object has another type of object. So I'm going to diverge from the book here because I think my example is really good and I do it a lot. So let's go ahead and make a new package. And we're going to have some fun. And then we'll have to continue on this, because 20 minutes isn't enough to do the whole example. But it's a good example. So new package, animals, new, and so now let's go into the, I want this over here, refactor, there's nothing for refactor in there, new class. Now let's create the animal class. Right. So this is an animal class. And what we're going to do is that we're going to build a bunch of objects that represent different types of animals. Okay? And the idea here is that we want to reuse as much code as possible. Okay? And Java provides mechanisms for doing this. Okay? So an animal, we're going to just go and with like some basic features that define an animal that aren't too complicated, right? Objects require a couple of things. They require three things. You need fields, constructors, and methods. So fields are the adjectives that describe it. So this is a has a relationship. An animal has a string. That string is a name, right? Every animal has a name, right? So this is a has a relationship. Private string name. Also, like maybe each animal has a double size. Right? And each animal also has maybe a color, and I'm just going to, and I'll represent that with a color object. color, right? Each animal has its own individual color, right? And we can write constructors, right? An animal, and I'll just worry about the name right now. String name. I won't worry about the size, really. I'm going to keep it simple. We'll just concern ourselves with the name. So this dot name is equal to name. So we've set the name. And it's probably a good idea also to create like a default name. So public animal. If we don't give it a name, then we can call the constructor using this name, right? And what this does, let's call it Andrew, because I might as well make myself the butt of the jokes here. So animal Andrew knows, this will pass essentially Andrew to this constructor over here. Okay. So now what? We need methods. What are basic stuff that animals do? Public animal. So public void they eat string thing, right? They eat animals eat things. That's a big feature of animals. They like to eat. And animals like to move. I'm not really going to model to behavior here, like in too much detail. That would be big thing. Now, animals move differently. All animals move very differently, right? A fish swims, a bird flies, and sometimes walks a bit. Snakes slither. All sorts of animals move differently. If I'm an animal, I don't really know what type of animal it is, so I'm just going to say system.println this dot name this animal plus moved generically, right? And same thing with eat. Out this dot name plus 8 plus thing, right? No this there because thing is a local variable. Normally, whatever normal is, right? So now I'm gonna go ahead and like break a rule here just for simplicity, just to make it easier. You can totally put, even though I said not to do this, you can put a public static void main in here to run the class. So you can create an animal A is equal to a new animal over here, right? Just because it's not advised to do it doesn't mean you can't do it. And so we can do a dot move. Andrew moved generically, right? A dot eat a tasty snack. Andrew ate a tasty snack normally. Okay, right? Not too much. Animal can be anything there. I can say if it was an animal, Ari the aardvark, right? I can do that. Ari the aardvark ate a tasty snack normally. So nothing too exciting here, right? Just we've modeled an animal. Animals have names. They can move, and we can build animals. Okay. So the key here, though, is that if we want to make different types of animals, this is kind of a blueprint for making like weird, kind of like generic animals. So say I wanted to make something like a reptile now. Okay. So let's go into project, animals, new class, reptile, right? So reptiles, right, just like animals, they have, a private string name. Oh my God, I'm going to have to copy paste everything, aren't I? Right? The reptiles have names, right? They have colors, they have size, you have a constructor for them, and all reptiles eat and move. And really the only thing that's going to change is the methods, right? Reptiles, now that we have reptiles, we can say that reptiles eat a bit differently than a generic animal do. And reptiles move a bit differently than, animals, right? Really all that changes is the way they're doing their methods. And it's really kind of a pain in the butt for me to copy and paste all this stuff, right? And then work out the changes. Yes, I want to import that one. See, it's already annoying me because I have to do that kind of stuff over here. Move. Oh, I'm going to copy paste it wrong, right? Already annoying, right? And then I have to make its own individual constructors over here, right? Alt Shift, Control. Wait, no. Oh, what did I do there? Okay. I just locked it accidentally because of the function key. So generate the constructors for name, right? And I have to make that. So it's just a bit of annoyance, right? And it also, when I do it like this, I lose a bit of subtlety. And that bit of subtlety is the fact that that reptiles are a type of animal, right? Reptiles are a type of animal. So I want to kind of do two things. I want to say that a reptile is an animal, right? That's the true statement. And I want to basically reuse all this code without having to go through and copy paste that. And so there's an easy way to do that in Java. And it's by adding another field here. It's called extends animal. So each class can extend one other class. Every class can extend one other class. class. In fact, every class does extend one other class. If you don't, Java will automatically extend the object class for you, which I'll get into in detail. But what the extends does is that it sets up an is-a relationship with every it sets up a is-a relationship, right? By saying reptile extends animal, we are saying a reptile is an animal. So now you get a lot of stuff for free now. What you don't get is a constructor. I'll get into that in more detail when we get in the next lecture. But one thing we're going to have to do is that we still have to write our own constructor, right? So I'll just go ahead and do that now. So public reptile Ralph. Public reptile. We'll go ahead and give him the default name of Ralph. So this dot. We'll just give him two constructors. And, with inheritance and, constructors can get a bit messy, but I'm going to avoid that just by doing this stuff. Reptile, this dot. String name. So right now it says that name. So then this year we have a new constructor here. It says that I can't access name because it's private to animal, right? Can't access name outside of another class because it's private. I'll just leave it blank for right now, and I'll get back how we can fix this later, right? There's a third variable there but for right now we'll just leave them blank. Okay. So we've got a name. So reptiles now have a name. And now if we do our own public static void main over here, we can watch this. Reptile R is equal to new reptile. And now I can do r dot move. And this is where it gets cool. Ralph moved generically. So I just built an object. Notice that reptile does not have a move method, right? It does not have a move method. Yet I called r.move. And it ran and it says and it did it. Where is r.move? It's an animal. Right? So Ralph can move because he's an animal. All animals can move, right? That makes sense. So we got the move method for free. We didn't have to copy it over, right? He also gets the eat method for free. The eat method for free. So reptile Ralph can eat thing. Some lettuce. Right? Ralph eats some lettuce normally. So it's just a animal. Right? And so that makes sense. A reptile is an animal. So it has a name, right? And we just used it there, right? I didn't set up a name variable over here. Right? There's nothing up my sleeve here. There's no name over here. Where is that? Well, if I go and say this.name, it says, hey, it's at the animal class. That's cool. Okay. So now, mind you, I probably don't want my reptile to just eat, normally. Reptiles, they've got sharp, pointy teeth, so they crunch stuff a lot of the time. So let's go ahead and update that. So this thing that I just did over here, reptile extends animal. This is inheritance. We inherit a bunch of we inherit the methods and the variables from our parent class. We do not inherit the constructors, but we inherit the methods and the variables from our parent class. And if we want to change them, we can by doing something called overriding. So public void eat. Now you override by creating a method with the same name and parameters as the as your parent. So public void eat string thing. I don't have to call it thing. I could call it something else. It just has to be the same types. And then we can do system.out print line this dot name plus 8 with plus thing plus with a loud crunch. Okay? Ralph ate some lettuce with a loud crunch. Kind of makes sense for lettuce right there, right? So we overrode the behavior, right? But if we tell Ralph to move now, reptiles move in all sorts of different ways. Some of them climb, some of them scurry, some of them do, some of them slither. They're all different types of things. They all do different types of things. Now, Ralph moved generically. So what's cool is that every class inherits a class even if you don't tell it to. Like animal, it says, you might be going, well, I didn't extend anything over here. But when you don't extend something, then Java automatically puts a silent extends object over here. And these are an object holds all those methods that are useful for objects to have. The toString method, in other words, the method that gives instructions on how to print out something. The dot equals method, right? So when I go over here to reptile and I do r dot, and we see that it has move and eat and name and color, but it also has clone, equals, hash, toString. It's getting all these extra stuff from the object class. Now you might be going, wait, you can only extend one thing, right? Reptile is an extending object. Well, a reptile is an animal, and an animal is an object. So a reptile is an object. So literally, if you write every single class you write is some type of object. So everything in Java except for the primitives is an object. This is why we call Java. It was what makes Java an object-oriented language. Everything's an object except for those primitives. So, and when we did and when we were over here in the point method and we did the toString method, we were overriding object's toString method, right? It says over here, overrides method, right? This is my IDE giving me that data. And we had circle, and we overrode the toString method. That's what we did over there. All right. So I think this is a great stopping point. So this is, again, the last chapter that we have. The rest of the semester is going to be dedicated to learning these things, refining these things. These things can be interesting. So we're going to work on my goal is that we're going to work on some smaller things then, and then we're going to try to work on a single bigger project that's mostly done, that's actually completely done. That's my objective, to give you a project that's basically completely done, and I just want you to improve it.